Hey guys, this is Unit 8, and in this lesson we are going to be graphing factorable quadratics. To do this, you will need a graphing calculator to get your graphs, and then we will find the attributes based on those graphs. I wanted to remind you of a couple things before we got going. Standard form of a quadratic looks like this, and remember you need this form when you factor, so you might have to do a little bit of algebra to get it to look like that. And then of course this one over here is vertex form. Just a reminder, you do not have to memorize those for any kind of standardized test because they will be on your formula chart. And another reminder, remember the domain of all quadratic functions is negative infinity to infinity, and remember this means all real numbers. If it's a plain old quadratic equation, it's all real numbers because they're the ones with the arrows on the ends and you could plug in anything you want. And of course we could say all real numbers by making that symbol as well. So any one of those three things would be correct. This is unless, of course, it's a real-world situation. If we're talking about baking cupcakes or populations, that would be different. But plain old equations, it's always all real numbers. So for my first equation here, it's number 1, and it wants the factors and the rest of these attributes. Let's factor it first. So remember, this is in standard form, and if I want to factor a trinomial, I would put t-charts under the first and last. X times x makes x squared, and the only thing that makes multiplies to be 2 is 1 times 2, which is nice for us because if we add them up we would get 3. So the factors here for this function, and you can put y equals on the front, it's the same function, x's go in the front, 1 and 2's go in the back, and everybody is positive. So there you go, there are the factors for this. Now let's go ahead and graph this. I have mine graphed on my calculator screen, and so at this point we could press Control T and we can get some points here, and I'm going to scoot up. Okay, there it goes. Okay, so -4, 6, -3, 2. I'm going to go ahead and take a second and I'm going to graph this on my screen. So I'm going to pause my video and then I'll come right back and we'll do all the attributes together. Okay, I wanted to go ahead and come back and talk about this just for a second. As I was graphing these were the pretty points from my graph, but when I looked here, the -2 and -1 were both at 0, so I know at some point in between them it has to dip down and I can see this. Do you remember what that's called if it's at the bottom? It's called a minimum. So I'm going to let my calculator do this for me, which helps us on this problem. I'm going to go Menu, and I'm going to choose Analyze, and I'm going to choose Minimum. Remember, you don't want to click on it. You want to click on one side and drag across it. So now I know there is a minimum value at -1.5, -0.25. So I'm actually going to put that here. So there is a min, and it is at -1.5, -0.25. So when I graph this, it's going to be really tight, maybe something like that. And then I can go ahead and finish graphing out my quadratic. Sorry, I missed these points a lot. So there we go. So now we can start doing the rest of these. For domain, I know my domain is always all real numbers because this is just an equation. And then for the range goes with y. And so remember, when you do this, you would have to start down here at the bottom, and then this graph goes up from there. The nice thing about this, I already found that bottom point, because we know this point here is -1.5 and -0.25. So 0.25 is the lowest y value, and it goes up. So my range would say y is greater than or equal to, because that point is there, -0.25. So there you go. So that answers that question. The nice thing about this is also my vertex. So -1.5, -0.25, because remember your vertex is your turning point and it just happens to be a minimum. Axis of symmetry would be what cuts right down that middle, and remember that goes with this value. So the axis of symmetry in this case would be x equals -1.5, and now we need x-intercepts, y-intercepts, and solution, and our calculator will do those for us. So my x-intercepts are those two values, so I'm going to go Menu, Analyze, and remember those would be called zeros on this list. And I click and drag across the first one, and then Menu, analyze, 0, and I have to click and drag across the second one. So those are my x-intercepts, so let me write those down. And remember, you can write these in coordinates, or you can say -2, -1. Those are the two places they go. And also, this guy here and this guy here say the same thing. So if I said, what are the solutions? I'm just going to repeat that. -2, -1. And then for my y-intercept, on my calculator, if I press Control T, I look for where x is 0, and that's my y-intercept. I'm sorry if it's cut off a little bit, but it should be 0, 2. So on my paper right here, I would say 0, 2. Or you can say y equals 2, either way. So your calculator will really do a lot of this for you if you just can find a few things on here. So let's go down to number 2. So number 2, here it is. I'm going to graph mine in just a second, but let's factor it first. This factoring problem is a little bit different. Notice this is a difference. And this guy here and this guy here are perfect squares. So this is a difference of squares. So you would say, the rule says, we put x's in the front, we put 5's in the back, one will say plus, one will say minus. I do want to point out, if you didn't remember that that's a difference of squares, you actually can t-chart this. And you would say x and x, and this would be 5 and 5. But in order for there to be 0 x's in the middle and it multiply to be this, 1 would have to be a negative, because if you add those up you'd get 0, but of course if you multiplied you would get the -25. So there's my factors, x plus 5, x minus 5. I'm going to pause my video, I'm going to go to my calculator, graph this function, and then I'll come back and we will find all this information out. So give me 1 second. Well, this was a fun graph to put on our paper. So the axes and stuff over here are definitely not big enough for this graph. But if you look at my calculator, this was my table, and I really plotted what I could, but I ran out of room really quick. So a couple things I want you to notice. I can definitely tell this graph is going to have a minimum down here. This number just didn't go low enough. So I'm going to double click, so press enter twice on that where a cursor's going, and I'm just going to change this. Let's make it -30. Let's see if -30 works. There you go, -30 works. Now I can see this bottom value here. I know a lot of this stuff goes with that, so I'm going to go ahead and find this guy down here because I know he's the vertex. In this case, he's a minimum. It will help us with things like axis of symmetry and all that. So I'm going to go Menu and Analyze, and he is a min, and I click and drag, and I got 0, -25. Now I can't actually graph this, but to help me out on here, I'm going to put, we have a min at 0, -25. That means the vertex is 0, -25, and it's going to be somewhere down here is what that is. Remember, the range would go with this, is what this goes with, and since it's a minimum, that means it starts at -25 and it would go up. So to be higher than -25, you would need a greater than or equal to sign. The domain, of course, is always all real numbers. Good job. And you can say this anyway. If you want to say -infinity to infinity, that works also. Remember, the axis of symmetry is going to split your vertex, and it always goes with the x. So this would be x equals 0. So if you want to say that, you can. It splits the vertex. And then the next three things, of course, we can use the calculator for. So just a reminder, when we find our x-intercepts, they also give us our solutions, and then the y-intercept would be from the table. So here's one x-intercept, here's the other. Menu, Analyze, 0, click and drag, so there's one. Menu, Analyze, 0, click and drag, there's the other. So I'm going to add these in. And I'm going to repeat it over here. And to find the y-intercept, we press Control T and we look for where x is 0. Since we already have that, I'm going to write it here. I know it's 0, y is -25. Or you could just say y equals -25. So either way, you can write that as fine. So what we're going to do for the third problem is I'm going to help you with the factors part of it, and then you are going to finish the rest of it on your own and type your answers in on Canvas. The one problem we have with factors is this form does not work. So we're going to need to multiply this out. Remember, x minus 5 squared is x minus 5 times x minus 5, and we're going to set up a box and multiply this out. So I'm going to bump over here. Here's my 2 by 2 box. Here's x minus 5, x minus 5. So this is x squared minus 5x minus 5x, and this would be a positive 25. These guys are the same, so this becomes x squared minus 10x plus 25. This minus 1 just drops down, and so here we go. Now if I want to factor this, I do need to combine these, and I'm going to write that over here. So I have x squared minus 10x plus 24, and this is what I would T-chart. So x and x, and then everything that equals 24, but remember it has to be a negative 10 when you add them up. So even if, like you said, 12 and 2, they would both have to be negative in order to multiply to be positive to add to this. So there's a problem there. So I think it's negative 6, negative 4. Negative 6 times negative 4 is positive 24, but when you add them up, you would get a negative 10. So now I know our factors are x minus 6 and x minus 4. I know there was a lot of algebra there, but really when you go on your calculator to graph this, I just type mine in like this, and then I can hit Control-T and do all those values. I can see just by looking at this graph, it definitely has 2 zeros, and then this guy here would be a minimum when you find it. So use what we did in this video to help you find the rest of these, and then type your answers in the assignment in Canvas. And as always, if you need help, please ask for help. We are so happy to help you. You guys have a great day. See you soon.